Jai Hind everyone, I am Mohan Sharma, Assistant Professor from Ajay Kumar Garg Engineering College. This is video lecture for Power System and Operation Control, KEN 070, it's AKTU code. And here we are going to cover a topic which is SCADA and EMS. So basically SCADA is a supervisory control by which we can control the operation of the whole power system from a particular center, that is basically known as control center, and from that center you can have the values of the parameters which are basically dealing with the power system working. So let's start this topic. So firstly, we are going to study about the energy control center. So what is basically energy control center? So if as the name suggests, energy control center, so it is just like a center from which we can control the process of the power system. So if I'm talking about the process of power system, what is basically process? Just like generation, transmission, distribution, and operation of the circuit breakers, isolators. So all these operations can be controlled from a particular site. That site is known as energy control center, right? So this energy control center is equipped with some special type of just like softwares, hardwares, right? So in this we can have software which is named as SCADA, which it's abbreviated as Supervisory Control and Data Acquisition System. So this is basically a software which is required to collect the data from the various sites of the power system, and this data is being collected, and just like the data acquisition is basically the collection of the data and then monitoring of the data. So monitoring of the data as well as the operation of the data can be carried out with the help of SCADA system, right? So SCADA is basically a software which is used for data acquisition system and monitoring as well as analysis point of view. So the energy control center, that is ECC, has traditionally been decision center. So we can say that this is a decision center as well, because just like if analogy is being if I give you an analogy, you can have a station controller, right? Just like there are number of trains or number of platform at a railway station, and let's just like say 10 or 12 trains are there which have a regular duration, regular time of their arrival. So which train has to be come on which platform, this is being controlled by the station control center, right? So and just like the path of the train is being directed towards any platform, similarly we can have the load sharing in power system. So the amount of load which is available in the power system at a particular time, so the amount of load which can be shared or which has to be shared for a particular generator, that decision or that decision making power is with energy control center. So the basically energy control center is a area or just like a room in which some supervisors or persons are sitting over there, and they are basically taking the decision depending upon the situations of the operation of power system. So we can say that this is decision making center for the electric transmission as well as generation and interconnected systems, right? So interconnected system is basically we will deal with the area 1 or area 2, just like two areas are there, and in all the individual areas there are their own generators are there, transmission system are there, distribution. So if one particular area is there in which your generation is surplus, or we can say that if deficient amount of generation is there, load requirement is higher, so and under that condition the power can be transmitted or demanded from the second area, so that these areas can be satisfied properly, and the transfer of the power is taken with the help of tie line over there, right? So these are basically interconnected systems. Now the ECC provides the functions necessary for monitoring and coordinating the minute by minute physical and economical operation of the power system. So basically under the monitoring point of view, so monitoring is basically just like looking through the system or just analyzing the system throughout the working. So you have minute by minute, okay, so minute by minute data is available for this controlling or analysis point of view, right? So in order to have an efficient power system operation and control, various control centers have to be operated in a hierarchical manner. So yes, it is just like an organization. If you have to run the organization in a efficient manner, so you must have a hierarchy over there. So what is hierarchy? It is the levels into which the operation of organization is being divided. So let us take an example of a college itself. So basically at the top most there are management people, after that director level is there, after that HODs for each department, after that professors, associate professors, assistant professors, then lab staff, working staff. So all these comes under the hierarchy. So all the levels have to work properly so that the organization can function smoothly and efficiently. So in this manner only your power system or the control centers have to be work in a very efficient manner, in a hierarchical way, manner. So if we talk about the hierarchy in power system, so basically there will be a topmost authority which will be looking out the whole area. That is, if I talk about India, the whole India will be covered by one energy control center, that is NLDC, which is known as National Load Dispatch Center, which is situated in New Delhi. So for that particular NLDC, the function has to be look after all the processes which are being taken care of, which are being taking place in the functioning of power system, right, all over the India. But although it is very much difficult for NLDC only to look after all the processes which are taking place all over the India, so there are several divisions. So whole India is being divided into 5 regions: northern, southern, eastern, western and northeastern. So under those regions several states are there. So under those levels there are state LDCs are there. SLDCs are known as state LDCs, and controlling the whole state for a particular control center is again a very difficult task. So these state LDCs have several sub LDCs, right? So sub LDCs will be taking care of some areas. Basically sub areas are there. So basically what you can say, the whole controlling is divided under several levels. So it is obvious that if I have to control a particular area or a small area, it is basically much more easier than if I have to control a area which is on the larger scale. So yes, the work is being divided by every sub LDCs. So that there are lastly RTUs basically remote terminal unit. So those remote terminal units are basically used for calculating or getting the data, fetching the data from the substations, so that these data can be fed up to the upper hierarchical level. So they are basically taking the data or fetching the data from the substations, taking it and giving it to the sub LDC. Sub LDC will upload the data to the cloud, and from that area or that particular cloud the data can be accessed by any of the levels, right? So in order to have the efficient power system, you have to several hierarchical levels are there. Now there has been level decomposition of control centers in the power system. So basically level decomposition, what I was talking about, it is actually the level decomposition. So there are 5 levels of power system in India. So and if we talk about the control centers, there are 4 types of control centers. First is local control center, which is at the lowest level, right? So lowest level will be the local control center. Above those there are area load dispatch center, which will be concerned about a larger area. A number of local areas will be there under this area local dispatch center, load dispatch center. After that, state LDC. Okay, so state LDC will be concerned about all the area load dispatch center. After that, regional dispatch center, or basically regional control center. So regional, just as I've told you, there are 5 regional so load dispatch center. So basically regional will take care of state will take care of area will take care of load control center, right? And NLDC, the 5th one will be NLDC, that is National Load Dispatch Center, that will take care of all these areas, right? So there are several components of the energy control center. What are those components? The system control function traditionally used in the electrical utility operation consists of 3 main integrated subsystems. That is, firstly is EMS, that is energy management system. Second one is SCADA, supervisory control and data acquisition. And third one, which is actually important one, right, So the communication interconnecting the EMS and SCADA. So EMS and SCADA, they are two different quantities and these two quantities have to be maintain a communication between both of them. So for these communication, you require a communication system, better or best communication system, so that they can communicate efficiently and effectively. So in general language, if we talk about, so there are basically two, that is EMS and SCADA, but actually there have to be third, that is communication interconnection. Although communication system is often thought as a part of the SCADA only. So SCADA is basically monitoring software, and as well as we can say that the data is being transmitted from one area to another area, or one site to another site. So this communication system is treated as the part of the SCADA only. So that's the case, that's why this is being sometimes neglected. So figure on the next slide, plot the block diagram illustration of the modern energy management system, comprising of initially load forecast and scheduling, SCADA security assessment and analysis, and finally the optimal power flow constraints on the economic dispatch. So basically we are going to now deal with SCADA and EMS, right? So yes, this is the block diagram by which you can understand the SCADA. Basically, see how the all these SCADA work, and how the data is being transmitted from the site level to the topmost level, right? So just see over here, these are the substations. Okay, so this is the substation at which, just like we can say that the one particular substation is there, and on that substation a number of devices are connected. So those devices will be having some parameter value, and those parametric values can be calculated with the help of these RTUs. Okay, so let us say that these RTUs are the we can say that these RTU are basically the measurement devices. Okay, so these will measure some quantity, and what from where they can be calculating these, they can be calculating, or these monitor can be they will be calculating these parameters from the monitor devices. These monitor devices will be just like a transformer, the primary secondary voltage of a transformer, generator, the generating voltage of the transformer, sorry, generator, not transformer, and voltage level, phase of the voltage generated. So all these parameters are calculated by RTUs. Okay, now these RTU, what these RTU will do, these RTUs will feed this data to one sub LDC. Okay, so above them there are sub LDC. So these sub LDCs are basically responsible for uploading this data to the cloud. Okay, so cloud is basically, you must be knowing about the cloud. Basically it is a tremendous amount of power data can be stored in the cloud. So these data, or if I'm talking about the a large amount of the data, you require cloud, because a number of parameters are there, a large number of parameters are there, and you are taking minute by minute calculations. They are minute by, or even though there are second by second parametric values. So you will be having a large data, basically that is known as big data. So that's why there are some cloud storages are there. So you can just upload the data to that cloud, and you don't require any of the hard drive or hard disk separately, so that you can have those data to be fetched, or there is no need, just like you upload it and you can fetch it, just like the Google Drive is there, right? So sub LDC will upload the data to the this one cloud, and SCADA front end computer. So here there are several devices, or there are several blocks which can show the SCADA host computer. Here are the SCADA host computer, and which are being dealt with the energy management system. So basically this is your control center. So from here the controlling of the whole power system will be taken care of, right? SCADA host computer, basically there will be if I talk about how the how this energy control center looks like. So you must have watched just like some space launch vehicles are there. So there are some operations just like PSLV launch vehicle is there. So when any PSLV is launched, so you can just like when in the movie Mission Mangal, you must have encountered a control center from which the control of that rocket is being carried out. And you can just notice that there are big screens over there. So on that screen there are several sub parts are there, and all the parts are some depicting or representing some fuel value or the temperature or velocity, etc. Some parameters are being monitored and displayed on the screen. So you can just imagine this is the SCADA or energy control center from which you can control or analyze the actual controlling of the power system, right? So this is actually that area only, right? Now actually what happens, planning and analysis functioning as there. So basically there are human minds behind every control action. Okay, so this SCADA system is there. So you can have separate rooms or separate cabins or separate blocks for planning and analysis function. So once you have planned the output, or once you have planned how much load has to be given to a particular generator or a plant, so after the planning you can execute it or give the instruction to the SCADA host control system or SCADA host monitor, or basically this EMS, and it will be communicated with the help of local area network, that is LAN. So this communication is mandatory. And after that, this is the controller, and this is the screen of the SCADA. Just you can see the screen of the SCADA. So communication network has to be established between these communication systems and networks as well. Oh sorry, this SCADA front computer. So you can just you can have an analogy between these and computer system. Just like computer is a output device, so you can whatever you type with the help of keyboard. So from that, this is the input to the system, and CPU is the basically mind of the computer, so that it can function or program any kind of algorithm or any kind of functions it is being instructed of. And after that, the display will be shown on the monitor. So this is the CPU of the system, this is the basically planning commission, and this is the output. So this is how SCADA and DMS work in unanimously function or work together with each other, right? Now what is SCADA? What SCADA does is basically SCADA measured values, that is they are analog values. Okay, so actually they are analog value, they have to be converted. Okay, so they are the measured value, and that measured value is what is the measured value? Measured value is megawatt, that is power, real power, MVAR, that is reactive power, voltage, hertz, any frequency, and transformer tap position, whatever tapping are used by the transformer. So these are the data. Basically I am talking about the type of data which will be available. Okay, and open close status information, if open close status of the isolator will be there, circuit breaker will be there. Okay, these are the analog data, and digital data will be circuit breaker, isolator position, on and off. So you can have this digitized data just like 1 or 0. So 1 will be depicting your on position and 0 will be depicting off position, right? Then transmitted through telecommunication channel to the respective sub LDC. As I told you, these data, all data are being transmitted with the help of communication network to the sub LDC, right? Then secondary side of the current transformer, that is CT, and the potential transformer PT are connected with the transducers. These are the important part of the SCADA. Why? Because all the data which is measured has to be converted to a quantity which will be displayed or which can be functioned of, right? So we can have some operations on the data. So if we are having a particular data, just like if analog data is there, so if it is not understood by the the person who is working over there or supervisor, so it is of no use. So this has to be converted to the one particular type, so that you can have the proper analysis of that data. So that transducers are basically used for converting any kind of signal to your electrical signal. Okay, so that you can have some calculations or monitoring or manipulations, whatever the thing is required by the customer or this supervisor, right? The output of transducer is available in DC form, then it has to be if it is required, it can have in DC form, as well as you can convert it into the AC as per the requirement of the measurements. Okay, so it is in the range of 4 milliamps to 20 milliamps. So DC works in this range only. Okay, so basically you can have these currents in the form of in this range of, and but this range of the can be termed as, or we can have this range with the help of current transformer. So see, this is very much lower amount of current. Why? Because you have used current transformer and potential transformer. So the basically current transformer and potential transformer are the measurement devices which operates in the power system, and basically these power systems have very high amount of current values and voltage values, and you might not be having these much higher rating measurement devices. So these transformers convert your higher level of current or voltage to the lower level, so that we can have a proper measurement, right? So that's why the DC current is in this 4 to 20 milliamp range, right? Analog to digital converters in this current into binary pulses. So analog to digital converter are also required. Different inputs are interleaved in a sequential form and are fed to the CPUs and RTUs. Okay, so the output of RTU containing information in the form of digital pulses is sent to the sub LDC, and this sub LDC will receive the data from RTU and it will fed to the data servers, right? So data server is basically cloud only. So in general, a SCADA system consists of a database is there, display is there, and supporting programs are there. So you can have all these things under SCADA, right? Now there are several points or several sub classifications of not classification, they are the parts of the SCADA that all these combiningly form your SCADA system. So and in this first one is communication. So communication systems has to be very good, right? So communication system are basically dealt with sub LDC computer communicates with all the RTUs stations under its control through a communication system, right? So RTU polling, message formatting, polynomial checking, and message retransmission on the failure of the failure are activities of some communication system functional areas, right? So basically all these are the functions of the communication system that has to be carried out, right? Then data processing. So after receipt of data through communication system, let us say that you have received the data, what you will do of that data, right? So you have to analyze that data, so that data has to be processed. So what for these data will be processed? For predicting the future values, or predict, or just having the historical criteria, historical scene of that particular power system, or let us say that if any kind of fault has occurred and you are not aware of what was the actual case by which the fault took, or in that case fault occurred. So you can have some historical data from that. You can predict that this might be the condition from which this fault would be occurred, would have been occurred. So you have to process the data. So after receipt of the data through communication system, it is being processed, and data process function has three sub functions, that is measurement, counters, and indication. So firstly you will measure the data, indicate it, and after that counters will be there, right? So measurement, what are measurement? It retrieved from RTU are converted to engineering unit and linearized if necessary. So firstly you will be requiring SI units, right? So engineering units are basically the units in which we will be processing the data, right? So the measurement are then placed in the database and are checked against the various limit violations which exceed the generator or high or low. So there are always some limits under which the power system must work. Okay, so under that limits we can have our particular, under that limits we can have the particular, or we can say that the safe side in which the any kind of particular machine would be operating, right? So under that condition we can have the this can be operated under these conditions, right? So it can be having a low limit or higher limit, so they have to be operate under those limits only. Okay, now the system has been set up to collect counters at regular intervals, typically 5 or 10 minutes. So there are intervals, so just as I told you, minute by minute data is there. So obviously you can have minute by minute, second by second, hour by hour data, so several minutes by several minutes. So typically 5 or 10 minutes are there. So under this duration your data is being measured, and at the end of an hour the unit is transferred into the appropriate hour slot of 24 hours or archive history. So if you are not require that those data, that has to be transmitted to the archive, or we can transmit to the historical part, right? After that, indications. So indications are associated with status change and protections. So basically indication are basically deal with alarming system or blowing off LED, blowing off alarm. So if any value or any parameter is being getting out of the operating range, so under that condition, firstly alarm will be there, some display unit will be there, so that you can, the operator or the supervisor over there can have a view of that, yes, there are some difficulties, or there are some differences into the operation, normal operating conditions. So your system is being under some disturbances are there, so we can have those corrections by just looking at the indications. So these are the indication status. For those statuses that are not classified as alarms, logs change on the appropriate printers and also enter into a cyclic event list. For those statuses which are defined as an alarms, their indications goes into the alarm, and entry is made to appropriate alarm list, as well as in the alarm list an audible alarm is there, right? So under that condition you can have the appropriate action taken place, so that you can just carry out the or you can carry out the prevention of the power system over there. Then alarm event loggings are there. So whenever the alarm is there, whenever time, or for how long the alarm is blown, all these are basically logging. And logging is there basically, what is logging over here? It is the just like call logs. You have call logs in your mobile, so dial calls are there, received calls are there, duration of the calls are there, so how long the conversation has taken place, right? So these are the logs basically. So alarm log, event logging is there. Okay, so the alarm log event facilities are by SCADA process system, and they are grouped into different categories. So these categories can be, if limit violation is there, so there will be some prevention action that has to be taken care of, so that your system do not go under further failure, right? Then manual entries are there, so they are basically obsoleted one. So manual entries basically once the process is taken place, or you can have the you are having a data for a particular amount of a particular time of data, so under that data you can have manual entries as well, right? So these are basically uncovered by RTUs, or some problem is going to RTU. Under that condition you have to, but data is required. Okay, so if RTU is not available, so you can have manual entries over there. So manual calculations has to be taken care of. After that, averaging or measured value. So as an option to this SCADA, the SCADA system supports averaging of all the analog measurement. Typically averaging of all the measured values over a period of 15 minutes is stored for 24 hours. After 24 hours they have to be transmitted to the system, or they can be transmitted to the archive history, or wherever you can have. If it is of some use, you can just utilize it, you can save it. Otherwise it can be transmitted to the archive folder, or some archive folders are there, right? HDR, that is historical data recording. HDR, that is what I was talking about, archive. So it is the folder, just like we have archive in our emails also, so that if you delete some mails, or you can archive the mail, so that there is a particular folder from which you can have a dumping yard, so you can just put that data. So historical data is basically required, or historical data is the time duration, for a particular time duration you have historical data, so just like for 1 year or for 2 years, so these are the historical data available by the system. So you can analyze those data for predicting the future of the power system, or a particular site is there which are very much prone to faults. So under that condition, what kind of protection devices or protection schemes can be applied, so they can be predicted, or they can be calculated that how much protection requirement is there for a particular site. So historical data can help you over there, or basically historical data can also help when you have to install some new power plants. Okay, so for those power plants you must have historical data of that site, so that site also be taken care of. Interactive database generation, so basically interactive database is just like communication between the several levels of the power system. So sub LDC, LDCs, then RLDCs, regional load dispatch center, and then NLDCs. Basically these LDCs are sharing data with each other. This is basically known as interactive database. If you are having data, if those data cannot be accessed, or those cannot be processed, so they are out of no use. So just accessing the data and calculating, or whatever the manipulations you have to take care, so you can do it. Then supervisory control and remote command. So supervisory control and remote command is basically the controlling the operation of a system from a particular site, right? That is energy control center. Lastly, it is failover. A failover is of the substation is basically the action which is taken care of for just like it is just like a condition in which you try to control this, or it is just like the fault of a person or the supervisor or the person who is monitoring the system, who fails, or who by chance, by some accident, who misses the alarm, or all these loggings have been mixed and the fault takes place. So under that condition we treat it as the failure of the system. So this was all about the SCADA and EMS system. Thank you very much. Jai Hind.